Hello everyone. So in the previous class we were discussing about normal or Gaussian distribution and student T distribution. Both are important continuous distributions, normal and student T. Okay, both are important distributions. We are referring these because the properties of these distribution is having some standards. For example, in normal, we are having all mean, median, mode equal. It is symmetric. Okay, bell shape. Okay, and we are having a standard formula for it that I have written so many times. Okay, where nu and sigma are mean and standard deviation, and it looks like this. Okay, fine. This is normal distribution. And I also told that continuous data is seen in many problem statements. Okay, so definitely normal will be our reference plot. Since we are studying all these things under probability, so if we are having continuous data normally distributed, both these two things will provide you flexibility to perform sampling with data points that can be used ahead for different purposes. Student T distribution is also like normal distribution, but it is having thick tails. So student T and normal are just same appearance, but student T is having thick tail. It is not closing to the x-axis. This means thick. All right, fine. So both are important, and the way they are used means if you are having small sample of data, so student T is effective. If you are having huge sample of data, so normal distribution is effective. Okay, fine. So we can use these plots according to the purposes they are defined. There are few more things present here. That means a rule which came yesterday for normal distribution. Okay, that was your 68, 95, 97 rule. I want to put a light on this rule. So, this 68, 95, okay, let's consider 99 instead of 97. 68, 95, 99. This is an empirical rule. It refers to 3 sigma rule. Sigma, 2 sigma, 3 sigma rule. And it offers a simple and quick method for comprehending the distribution of data in a normal distribution. Let me share my entire screen now, so it will be easier for you to see where I'm referring to the notes. Okay, here it is. 68, 95, 99. This rule. So in normal distribution, there is a symmetry, bell-shaped curve that categorize a wide range of natural events and statistical process. That's why I told it is a reference plot. Many of the natural events, many of the statistical process, they can be represented with help of normal distribution or Gaussian distribution. I told you we are available with data which do comprises of such distributions. We can keep this as a reference. So if we consider it as a bell curve, the distribution is around average, mean. We are having a distribution around mean or an average. Okay, we can better comprehend this distribution by this rule. It states that 68% of the data, approximately 95% of the data, and approximately 99.7% of the data lie within 1, 2, and 3 standard deviation. What does this mean? So, data has a distribution roughly 68% within one standard deviation of the mean. In two standard deviation, 95% of the data, and in three standard deviation, 99% of the data. In other way, this rule can be implied on most data points that are concentrated around the mean, and less concentrated one moves in either of the direction away from the mean. Let's see it diagrammatically. And yesterday also I did made one plot regarding this also. I think I made like this. Okay, and I did shaded this portion, and I told that this is 68%. And I told you that I will clear this concept tomorrow. Okay, so here it is. This is 68%. So this is your mean. Okay, and most of the data is concentrated around the mean. That is assumed to be like 66, 68% of the data is present around the mean. Okay, so this is mean, and this is mean minus sigma, left hand side, mean plus sigma, right hand side. So these are the boundaries. This is 1 sigma. If we add one more sigma, so this will be 2 sigma, where we are assuming 95% of the data. And if we add one more sigma, this will be nu minus 3 sigma and nu plus 3 sigma. That means we are assuming 99.7% of the data around the mean. So mean we are taking as a reference, and we are talking about how much data is present around the mean, across the mean, left hand side, right hand side also, because we are referring this plot as a bell shape, symmetric. So we are just according to our parameters nu and the sigma, because the entire formula of normal deviation is based upon this only. Okay, so in regards to that, okay, we are showing the distribution of data across mean. So just left hand side, right hand side, add and subtract sigma. This is one standard deviation. Add one more, subtract one more, this is 2 standard deviation. Add one more, subtract one more, this is 3 standard deviation. Okay, so it implies the understanding and analyzing data distribution. So we are totally focused upon distribution of the data. We are having nu and sigma only to say, to speak. These are the terms we are available with. So how mathematically you can make someone understand that this is how data is present in the distribution? So you can say, okay, 68% of the data is present between this range. And then you can say 95% of the data is present between this range. And 99% of the data is present between this range. This is how you can tell. This is your rule. Okay, that's what it means. All right. So, yesterday I told you that I will talk about it. Then here is the explanation about the rule. Okay, fine. So, that's one thing I need to talk about, the normal distribution. Then, in student t distribution, okay, I need to talk about the probability density function of it. Okay, that means how you can define student t distribution and what is degree of freedom. These are the two things I want to talk about. So here is a formula for student t distribution. Gamma v plus 1 by 2 under root of v pi gamma v by 2 1 plus t square by v minus v plus 1 by 2. I know that it's hard to learn this formula because normal distribution formula is very easy. Okay, we remember this formula. It's very easy to remember. But remembering this formula, this function for student t is tough because we have included gamma function here. And we are having degree of freedom also, which determines the shape of distribution. Shape, dimension of the distribution. Okay, in how much dimensions the data is present? 2D, 3D, whatever. So shape is degree of freedom. As the degrees of freedom increase, the t distribution approaches to the standard normal distribution. That means, understand it carefully. I told that the difference between normal and student t is normal when you are having a data which is so many features available in it, while student t is applied to a small sample of data. So this is big sample, this is small sample. Okay, a small sample means you are having some features only, some dimensions only. However, in this particular case, you are having many dimensions. Okay, but if the dimension increases, student t distribution will turn up to normal. It will convert it to the normal. If the degree of freedom increases, that means the dimension, the shape increases. If your sample, if your data sample increases, then your student t will convert to normal. Okay, so this is your entire population, this is your sample. Okay, this is another sample. Since this sample is small, I can apply student t to it, and this sample is big. So I have to apply normal distribution here. Normal. This is a student t. But if the size of this sample increase, increase, so student t will automatically turn out to normal distribution. Okay, that's what the math says. If the dimension increase, student t will turn up to normal distribution. This is important thing which you have to remember. Okay. Heavy tail I already told you. Bulky. Symmetry, okay, I already told you. The t distribution is also symmetric. It looks like normal only. All right, fine. So that's what it is having. Okay, fine. Applications, I told, especially in hypothesis testing, we are going to use it confidence interval that I will let you know. All these things now are present ahead. Okay, meanwhile, I need to talk about this formula. This formula is having gamma function and degree of freedom. Degree of freedom, just I told, the number of dimensions present in the data. 2D data, 3D data, that is degree of freedom. Okay, so what is this gamma function? Let's talk about it. See, in your engineering maths, I hope you have seen this gamma function. Gamma function is a function that extends the concept of factorial to non-integer value. Okay, the concept of factorial is extended. So the gamma function is defined by the integral like this: integration 0 to infinity t to the power z minus 1 e की power minus t dt. This is the formula for gamma function. Okay, so this integral computation the gamma function for complex number with positive real part. For positive integer, the gamma function is written like this: gamma n is n minus 1 factorial. This is how we do, right? This is gamma z. Okay, this is gamma z. This is how we do, right, in the integration format. It's a standard formula. I am not making it. It's a standard formula. So gamma z is equal to t की power z minus 1 e की power minus t dt. Okay, we are integrating t. That means the value of t will be from 0 to infinity. Okay, and for positive integers, okay, this is for this integral computation of the gamma is for a complex number with a positive real part. Okay, this is for complex number. Complex number you very well know, a plus ib. This is complex number where a is the real part, b is the imaginary part, and here it is saying a na, the real part is positive in nature. Okay, fine. However, for integers, for positive integers, this is how we can write gamma function. Gamma n is n minus 1 factorial, so gamma 4 is 3 factorial, that is 6. Easy. So why it matters? See, gamma functions are used in various areas of maths, including probability. So right now we are studying probability only. Okay, so that's why we are using gamma distribution, combination problem, complex analysis. Gamma functions are used, and student t distribution. Right now we are referring to student t. So here we are using the gamma function. Okay, so just remember this formula. What does gamma means? So for complex numbers, this is the formula for gamma: 0 to infinity t की power z minus 1 and e की power minus t dt, where z is a complex number. Z is equal to a plus ib. It's a complex number where a is positive, positive real part. But in case of integers, this is the formula: n minus 1 factorial. All right, fine. And degree of freedom, I just already told you. Okay, degree of freedom are used to describe the shape. Okay, so degree freedom is typically denoted by df is equal to n minus 1, where n is a sample size. Okay, n is the sample size. So degree of freedom is equal to sample size minus 1. Okay, so degree of freedom represent the number of independent pieces of information available. In sample, the degree of freedom often account for the number of observation minus the number of parameters estimated. Number of observations minus number of parameters estimated. So sample size of the data. What's the size? I'm talking about the dimensions. I can also say the number of entries present in the data. So the size is the rows and the columns ultimately. For example, we are having 1000 rows and 10 columns. This is the size of the data. So does it define the degree of freedom? That's what they are saying. Represent a number of independent pieces of information available in the data. In sample, the degree of freedom often account for the number of observations. So I am having 1000 observations minus the number of parameters estimated. So there are 10 parameters available. Ultimately saying size. So degree of freedom is n minus 1. Okay, that is the sample size. So I am having a sample of 1000 data points. So the degree of freedom will be 1000 minus 1, 999. This is the degree of freedom. If you are having a sample of 100 data points, degree of freedom is 100 minus 1, 99. So don't forget all these points. No one will tell, no one will teach. Okay, these are core statistical and probability. All these topics are being mixed up here. Okay, so why we are studying all these things? Why it matters? See, degree of freedom affect the shape of the student T distribution. When the degree of freedom is low, sample size is low, the student T distribution is having heavy tail. But when the sample size increase, degree of freedom increase. So this heavy tail will go down and down, and it will convert to normal distribution. I already told you. Okay, so as the degree of freedom increase, the T distribution approaches to normal distribution. Standard normal. Standard normal I already told you. Mean 0, variance 1, या sigma 1. This is standard normal distribution. Okay, so the gamma function is also important mathematical tool for extending factorial. So we are having factorials also. Degree of freedom is crucial for understanding and applying the student T distribution in statistical analysis. And we got the same formula for student T distribution, that is defining the degree of freedom, because we are taking a small sample size. Small sample. Applying normal distribution on small sample doesn't makes like so much effective. But with student T distribution, a small sample size is fine, because we are having the degree of freedom less there, less df, that is n minus 1. So student T is fine. Thick tail. Okay, so you may don't remember this formula, but at least if someone asks you what is gamma function, then you will tell. Okay, then you should tell about it. Okay, you're asking about gamma function. Okay, so gamma function is related to factorial when we are having integer value, positive integer. So gamma of n is equal to n minus 1 factorial, easy. But when we can need to calculate gamma of a complex number, then it is related to integral. 0 to infinity t ki power z minus 1 z e ki power minus z. Okay, e ki power minus, I think it's not z, it is dt, e ki power t dt. This is how we write in terms of complex number. So this is the gamma function to simplify a problem by using integration, by using factorial. Used in many of the applications, and I guess in engineering mathematics, students do study this gamma function. Okay, fine. Degree of freedom I already told. So these were the points which are present. Okay, in your student T distribution. Okay, fine. So this image I already explained you. Okay, all these example were explained. Okay, let me have a recap of another example. So if you are having two groups with sample mean 80 and 85, with standard deviation 10 and 12, sample sizes of 30 and 35, we can use t distribution to calculate probability such as difference in means by chance, assuming null hypothesis, that is two teaching methods have no effect in two. In this example, we are considering variability in the sample means, and that will provide accurate assessment. So just only the points which are marked here is we are having very low sample size 30 and 35. That's what it is telling. If your sample size is less, you are having two group of data. You are having sample 1, you are having sample 2. 30 points are present here, 35 points are present here. Mean is 80 here, mean is 85 here. Standard deviation is 10 here, standard deviation is 12 here. We need to prove something. Hypothesis. So obviously it's told to you that all this distribution, statistics, probability are meant to prove something. Hypothesis. Hypothesis is a statement which is given over a sample of the data, and it will be applicable to the entire population. So we have to prove something. So you can apply student T. Okay, we can do that. Okay, fine. So I think this is easier. Hypothesis testing will be learning ahead. Okay, fine. That will do. Okay. So just an example they have given. So in context of T distribution, the degree of freedom represent the number of independent observation. For example, in case of comparing means of two groups in T test, the degree of freedom would be the based upon the sample size of two groups. So degree of freedom, it's very important. I will be using here this thing in ahead in the hypothesis testing. I'll be using that. So one of the sample is having 30, one of the sample is 35. So degree of freedom for sample 1 which is having 30 size, it is 29, and degree of freedom will be 34 for another sample. Okay, and it affects the shape of the t distribution, as I already told. When the size increases, degree of freedom increases, it will convert to normal distribution. Okay, and in context of hypothesis testing, degree of freedom is used to determine the critical values for making decisions about null hypothesis. Null hypothesis is a statement which you are looking forward to prove, and there is one more alternate hypothesis. If null hypothesis fails, then we'll look out for alternate hypothesis. That is an opposite statement of null hypothesis. Okay, so degree of freedom in the T distribution represent the number of independent pieces of information available. And this is the formula for your probability density function for T distribution we have already seen above. Okay, so df plus 1 by 2. So now there v was written. V means df only. In the above formula, V was written. So df and V are same. So df plus 1 by 2, square root of df pi into gamma df by 2, and so on. Where x is the random variable, df is the degree of freedom, this is the gamma function. Gamma function I already explained you. What does gamma means? Okay, I already explained. Okay, so the mean of the t distribution is 0 when the degree of freedom is greater than 1. Remember, this is a property. Okay, and the variance is given as df upon df minus 2 if df is greater than 0. Okay, so there are certain properties. Okay, fine. And this I already told. As the sample size increases, t will approach to standard normal distribution, and this is also called a central limit theorem. A new name is given to it. That is central limit theorem. All right, and the t distribution is commonly used in hypothesis testing, particularly when the population standard deviation is unknown and the sample size is small. Okay, so when the sample size is small, we definitely use t distribution. We use its ability, degree of freedom, for t test, confidence interval, and other things. So that I will let you know. Okay, what is this t test? What is confidence interval? Okay, because the concept is just like simple. In hypothesis testing, hypothesis is a statement. Okay, again I am repeating. It is given over a sample. Over a sample. Okay, that this is the data we have collected from your city, and they are saying that it is like 90% of the chances that party A is going to win the election. So this hypothesis is also true for entire population. You have to prove it. For that, you have to apply testing. Okay. For that, you have to apply testing. Okay, fine. So definitely we have to use the concepts of T distribution, and it depends upon degree of freedom. So we'll be having some hypothesis testing techniques where this concept is applicable, that we will see. Okay, and conversion of T into normal. This process is called a central limit theorem. So now you should be aware of the concepts. What is normal? Why it is important? What is student T? Where we are using student T? Okay. What are the properties of these distributions? Okay, very much important. You should know all these things. All right. I hope this makes a sense. Okay, fine. So, just I want to say that. Okay, let me stop presenting.